Okay, we were talking about the fundamental counting principle when we stopped, and we were just saying that if you're creating permutations, that is, you're taking a group of objects and you are arranging them in order, then you can multiply the number of ways to choose the first item in the list times the number of ways to choose the second item times the number of ways to choose the third item, and so on, to figure out how many possible permutations there are. So when we talked about arranging the letters A, B, and C in order, how many possible ways can you do it? We talked about that for the first choice, we can think of it as having 3 empty boxes to fill. We've got this arrangement with 3 things, A's, B's, and C's, and we are not allowing ourselves to repeat any of those letters. So for the first box, the first position in this permutation, there were 3 choices, either A, B, or C. Then we already used the letter, so the second box has only 2 choices. And then the third box has just 1 letter left, and so there's only 1 choice. And that showed us that because of the fundamental counting principle, there are 6 ways to arrange A, B, and C. The letters A, B, and C. That is permutations of A, B, and C, if no repetition is permitted. Meaning you can only use each letter once. Okay, and that is 3 factorial. 3 factorial is 3 times 2 times 1. So this is one of those situations I was talking about when we talked about factorials, that it has to do with this idea of counting ways of doing things, or ways of arranging things, or ways of choosing things. And this is all about the study of probability, statistics, all those kinds of things. So let's look at some examples. If repetition is permitted, how many possible permutations are there of the letters A, B, and C? Okay, so we're talking about 3 boxes that we're going to fill, just like before, except now we can use each letter as many times as we want. So for our first box, the first position in our permutation, there are 3 choices, A, B, or C. For the second position, there are still 3 choices because you're allowed to use any of them again if you want. And for the third box, there are still 3 choices because you can use A, B, or C. You don't have to knock them out because you're allowed to repeat. So in this case, you're going to have 3 times 3 times 3, which is 27 ways to make permutation of the letters A, B, and C. 38.1, how many different ways can the numbers 3, 5, 7, and 8 be arranged in order if no repetition is permitted? So no repetition, you're going to arrange these 4 numbers in order, so you're going to have 4 boxes to fill, 4 positions for these letters. The first box, you've got 4 choices, 3, 5, 7, or 8. So 4 choices. Second box, now you only have 3 choices left because you have used one already and there's no repetition. Third box, third position, you have 2 numbers left. And for the final box, there will only be 1 number left. And so 4 times 3 times 2 times 1, or 4 factorial, is the number of ways to arrange those 4 numbers in order without repetition. So that's 24 ways. Example 38.2 says how many 4-digit signs, it really should be 4 letter signs since these are letters we're dealing with here. How many 4-letter signs can be made from the letters in the word equal if repetition is permitted? So we're going to make a 4-letter sign. So there are 4 spaces to fill. 4 positions, and we have 5 letters to choose from, E, Q, U, A, or L. So for the first position, there are 5 choices. E, Q, U, A, or L will go there. Repetition is permitted, so I can choose any of those 5 letters for the second position also. can choose any of them for the third position and any of them for the fourth position. So 5 to the fourth power is how many ways, how many signs you could make using those 5 letters 4 at a time in order with repetition. And 5 to the fourth is 625. Or you could say signs, because that's the question. How many different signs could you make? 625 different ones. Okay, a multiple choice test has 8 questions, and there are 4 possible choices to each question. How many different sets of answers are possible? Okay, so every single question has 4 possible choices. So question 1 has 4 possibilities. Whatever you choose for question 1, you've got 4 possibilities for question 2. Whatever choices you make for those 2, you've still got 4 possibilities for question 3, and so on. So whatever choices you make in previous questions, there are 4 more possibilities for the next question, and so on. So you've got 4 to the 8th power, because you can multiply all those together. So 4 to the 8th power would be the number of ways you could fill out this test. And 4 to the 8th power is 65,536. So if you were just going to take this test without studying and you're just going to guess randomly at your answers, your chance of getting 100 would be 1 out of 65,536. All right, how many 3-letter signs can be made from the letters in the word numeral if no repetition is permitted? So no repetition, you can only use each letter once. You have 1, 2, 3, 4, 5, 6, 7 letters to choose from, and so you have 3 positions to fill. The first letter can be any one of them, so 7 choices possible. You have now used one of the letters, so you only have 6 left for your second position, and now you've used 2 letters, so you have 5 left for your final position. So that is 7 times 6 times 5, which is 30 times 7, which is 210 possible signs. Okay, designated roots. The roots of an equation, remember, are just the solutions of the equation. They are the values that you can put into the equation to get 0. So when we solve a quadratic equation, when we find the roots, how do we do it? Well, we do it by factoring. So we factor this quadratic equation that all the things are on one side, set equal to 0 on the other side, and we factor it into 2 binomials, x here, x here. We're looking for 2 numbers that multiply together to give us negative 28, and that up to 3, that's going to be minus 4 plus 7. All right, so the factors are x minus 4 and x plus 7. You're multiplying them together to get 0, so one of them has to be 0. That's called the zero factor theorem. So one of these has to be 0. In order for x minus 4 to equal 0, x would have to be 4. In order for x plus 7 to be 0, x would have to be negative 7. So the roots of that equation, the solutions of that equation, are x equals 4 and x equals 7, negative 7. All right, so designated roots, now we're going to be having problems where they give you the roots and they ask you to write the equation. Okay, so we factored it, we found the solutions, those are the roots, x equals 4 and negative 7. So if you think about if you just had the roots to start with, how would you write the equation? Well, all you would have to do would be to write the factors you would get if you take the root and you write x minus one of the roots. That will be a factor. So one of the roots is 4, so x minus 4 is a factor. Negative 7 is a root, so you can see that x minus negative 7 was a factor, x plus 7. So if we're given the roots, that's all we have to do to find the equation. So this next problem says, write the quadratic equation with a lead coefficient of 1 whose roots are negative 3/5 and 1/2. So in order to write that equation, I just need to write the factors. X minus a root, x minus a root, and that's going to equal 0. So that gives us x plus 3/5 times x minus 1/2. And that's 0. And so we would want to go ahead and multiply that out so that it looks like a quadratic equation that we're familiar with. So if you FOIL it out, you're going to have x squared plus 3/5 x minus 1/2 x minus 3/10 equals 0. So x squared, so you can make that 6/10 x minus 5/10 x minus 3/10 equals 0. So x squared plus 1/10 x minus 3/10 equals 0. And so that's not a very pretty looking quadratic equation, but they wanted us to write the one with a lead coefficient of 1. It would look a lot better if we multiplied the whole thing through by 10 and got rid of those fractions, but they tell us to write the quadratic equation with a lead coefficient of 1. And so that's what we have. So we would just leave it the way it is. All right, now it says write the quadratic equation with lead coefficient of 1, whose roots are 1 plus the square root of 2 and 1 minus the square root of 2. So if 1 plus the square root of 2 is a root, then x minus 1 plus the square root of 2 is a factor. If 1 minus the square root of 2 is a root, then x minus 1 minus the square root of 2 is a factor. So this is the quadratic equation with those roots. And if we were to go ahead and multiply this out, we've got x minus 1 minus the square root of 2 times x minus 1 plus the square root of 2. And if we multiply all that out, we're going to have x squared minus x plus x squared of 2 minus x plus 1 minus the square root of 2 minus x square root of 2 plus the square root of 2 minus 2 equals 0. We have a positive x squared root of 2 and a negative x squared root of 2. We have two negative x's. We have 1 minus 2. We have a negative square root of 2 and a positive square root of 2. So the equation that we are going to end up with, which I'm going to have to write up here, is going to be x squared minus 2x minus 1 equals 0. And if you were to plug that into the quadratic formula, you should get these roots, 1 plus the square root of 2 and 1 minus the square root of 2. So let's just try it and see what happens. So if we plug the coefficients of this equation right here into the quadratic formula, we should get these roots because we created the equation in order for it to have those roots. So plugging it in, we've got negative b, so 2, plus or minus the square root of b squared, which is 4, minus 4ac all over 2a. That's 1 plus or minus the square root of 4 plus 4, which is 8, over 2. And if you reduce that square root, that's 1 plus or minus 2 square root of 2 over 2. And that is 1 plus or minus the square root of 2. And those are the roots that we started with. So you are given roots and you're supposed to write the equation. The way you do that is by taking each root, writing a factor, x minus the root, other factor, x minus the root. That equals 0, and that's your equation. All right, overall average rate. All right, let's remember that rate times time equals distance. That means that the rate is equal distance over time. It means time is distance over rate. So that is the fundamental thing you need to know about these problems that involve rates, times, and distances. Rate times time equals distance because the rate is distance over time, miles per hour, kilometers per second. So the overall average rate of a trip or some situation is going to be the overall distance divided by the overall time. So overall average rate is the overall distance divided by the overall time. So Larry and Bob drive for 100 miles at 50 miles per hour. They then drive 180 miles at 60 miles per hour. What is their overall average rate for the whole trip? So overall distance divided by overall time. All right, so we've got 100 miles and then another 180 miles. So 100 plus 180, that's the total distance overall, the whole trip. And then we have the overall time. Now, they didn't give us the overall time. We have to figure out what the time was. So if they rode 100 miles at 50 miles per hour, then the time for this part of the trip, T is equal to D over R. Time is equal to distance over rate. Distance was 100, the rate was 50, so the time for that part of the trip was 2 hours. So 2 hours right there. Then this part of the trip, they went 180 miles at 60 miles per hour, so the time for that part of the trip was distance over rate, which is 180, over 60, which is 3 hours. So 3 hours for that part of the trip. So their overall average rate for the whole trip, total distance was 280, and the total time was 5 hours. So their overall average rate is going to be 56 miles per hour. Kate and Rebecca drive for 100 miles at 50 miles per hour. They then drive 180 miles at 60 miles per hour. How fast must they drive for the last 120 miles to have an overall average rate of 60 miles per hour for the entire trip? Okay, so this is a little more complicated because we're looking for we want to have a specific overall average rate of 60 miles per hour, and we're given some information, and then we're asked what would need to be, how fast would they drive the third leg of the trip to get this overall average rate of 60. Okay, so let's just remember that the overall average rate is equal to the overall distance divided by the overall time. All right, so we have overall average rate, we want it to be 60. So we're going to put that here. The overall distance, we know they start out and the first part of the trip, they go 100 miles. A little bit later, they go 180 miles. And then the last leg of the trip is going to be 120 miles. So we know the overall distance. Now we're going to look at the times, the overall times, or each piece of the trip, how long that took, and then add those up. So again, we have 100 miles at 50 miles per hour. So the time for the first part of the trip, I'll just call it T sub 1, is equal to 100 over 50. Distance over rate is equal to time. So that's 2 hours for that part of the trip. For the second part of the trip, the time is distance over rate, 180 over 60. That's 3 hours. So 3 hours here. And then for the last part of the trip, 120 miles, we don't know what the time is. That's what we're looking for. So we'll just call it T sub 3, or we could even just call it T. But just to be different, I'll call it T sub 3. All right, so if we simplify this a little bit, we've got 60 is equal to 400 over 5 plus T sub 3. And if we multiply both sides by 5 plus T sub 3, we're going to have 60 times 5 plus T sub 3 equals 400. So if we divide both sides by 60, we're going to have 5 plus T sub 3 is equal to 400 over 60. We cancel one of those zeros. We're going to have 40 over 6. So that is 20 over 3. If we subtract 5 on both sides, 5 is 15 over 3, so 5/3 is T sub 3. So that last leg of the trip, they want to know how fast the person is going to have to drive. They're going to have to drive. All right. So that third leg of the trip needs to take basically 1 2/3 hours, 5/3 hours. And that distance for that last part of the trip is 120 miles. So rate times time equals distance. So we're looking for the rate. The time is 5/3 and the distance is 120 miles. So the third leg of the trip, we're trying to figure out the rate. We know the time is 5/3. We need to figure out the rate. So to get R by itself, you're just going to multiply both sides by 3/5. So 120 times 3 over 5. That is going to be 24 times 3, which is 72 miles per hour.